Hello? Hello?
Yes,
हा, आवाज येतोय?
होय सर येतोय.
कमी येतोय आवाज काय? तुमचा आवाज कमी येतोय?
नाही क्लिअर
हॅलो?
सर येतोय सर.
नाही क्लिअर
येतोय
येतोय
सर.
सर.
येतोय ना?
क्लिअर येतोय सर.
हो सर क्लिअर येतोय. हो.
ओके. तर नाईट जरा इंटरनेट इश्यू होता. ठीक आहे? ठीक आहे. We start today. We have already seen the drawing of the different substances. And we have seen this is how the formula is coming. Right? If you want to dry the material, to take the material in the petri dish, or it is a specific type of the dish is there, can take that material, weigh that material first, right? And weigh the material, weigh that material as well as dish with material we can weigh it. So this is called as initial weight of that substance. Then after this, keeping in the dryers or the furnace for appropriate temperature and appropriate time. After that, collect that material and again weigh it, right? So the difference between two weight, initial weight and the final weight of that substance. So that weight is called as a mass of the water sample, right? Means what is a water, what is the weight of that water containing in the sample, right? So this is the LOD. How we calculate the percentage of LOD? Loss on drawing is the mass of the weight of mass of water in sample divided by total mass of the vital sample. Which what is the initial weight of that sample? It is a this concept into 100. Then percentage moisture content, the mass of the water in sample, the same, and the mass of the dry sample. So how much after drying the material? So what is the weight of that drying material? Right, we can this can put up in the formula into 100. That is called as moisture percentage of moisture content. Then drying rate of that is equal to weight of the water in sample. So already we have seen, and divided by time. So how much time required for dry the material? Whether it is required 1 hour, 2 hours, 3 hours as like. Then weight of the dried solids, right? So and this is called as a drying rate. Means how much time required for dry the whole material in that. And the same calculation we can use for so next purpose. And this calculation, after this calculation,
Hello?
hello. हा,
Sir,
आवाज येतोय?
your voice is breaking.
आवाज येतोय?
हा सर येतोय आता.
क्लिअर येतोय? पण नेट गेलेलं आहे पुढं फक्त आवाज येईल तुम्हाला वाटतं. आवाज येतोय?
Yes, sir. Yes, sir.
Okay, we'll continue. Then after this calculation, so we can use we can plotting the graph, and this FMC is called as FMC is pre-moisture content curve. X-axis is content and moisture content, and the y-axis is the drying rate. Okay, so that is called as a drying rate curve. So in the drying rate curve, so we have seen this. It is A to B. So A and A dash, right? So this is called as AB. So what is AB? AB is the initial adjustment rate period. So initial adjustment of the rate of the period, initial adjustment period. So this is called as A to B. So what is in that period? During that period, solid is absorb the heat and to increase the temperature in that the solids, right? At the same time, the moisture begins to evaporate, right? Moisture begin to evaporate and tend to cool the dried solids. Understand it? So during the both this process is heating and evaporation. Understand it? Either we have to give the heat, and as well as same time the evaporate that moisture on the surface. Right. So both these step which are simultaneously. So at the same time the moisture is begin to evaporate and tend to cool that dried solids. So after some time, what will happen? The temperature is stabilized. So in this case, so temperature is stabilized, and the heating and cooling is the same, right? So temperature is stabilized and heating and cooling is the same, is equal. So temperature is equal. The temperature is equal at the wet substance as well as the dry air. Understand it? So this temperature, it is called as a the B. The B point is, it is a, in that B point, what is the temperature is equal to the weight bulk or the weight of the substance as well as the dried substance. Understand it? So this is called as a B. Understand this? So the next slide we see that, understand better. Right. Then from the B to C, the B to C, it is called as constant rate period. So what is meant by constant rate period? In that period, the temperature remain constant. The temperature and drying rate is constant, because the drying rate is not be, so it is totally a straight line, because rate of drying as well as temperature is same. It's constant, right? So that's why it is called as constant rate period. So at the same time, what will happen? The moisture is evaporating on the surface. Moisture is evaporating from the surface of the solids. At the same time, the moisture is coming from internal solid substance and which are coming to the upward side, coming to the solid surface, right? So this is continuous process of that. So that's why in this case the temperature remains constant, then drying rate is also constant. So in this case the moisture is completely begin to evaporate. In the same time the moisture is coming from inside of the solids and coming on the surface. Understand it? So rate of diffusion, so that's called as, the moisture is coming from the internal solids, it is called as a diffusion. So rate of diffusion. So in this case, the rate of diffusion is equal to rate of evaporation. Understand it? So rate of diffusion equal to rate of evaporation. So moisture content at the end of the moisture content at that point C is, it is called as a critical moisture content, right? So it means that in that content, the moisture content at that constant rate. Understand it? Moisture content at the constant rate, and that point it is called as point C. So that's why it is called as a critical moisture content. Understand it? So after that, from C to D, so this point is from the C to D. Avajitra, can you hear clearly? Hello?
Yes, sir.
Okay. From the C to C
Yes,
to D point, so this is called as a first falling rate period. Means in this, from the C to D, rate of drying is decreased. Means the rate of drying is very slow. Stephen, right? So during that period, it is called as a first falling rate period. In this case, during the this period, surface of water is no longer is replaced by the moisture containing from the inside solids. Understand it? So inside solids. So in this case, so the what is the, because after the surface of the water is evaporated, right? At the same time, what is the moisture contained in the inside? It should be coming to the outside, coming to the solid surface. Understand it? So then we make the continuous process, right? See if the solid, if the moisture containing the inside solids is not coming to the outside surface, right? What will happen? Right. So what is the timing gap in between? So that is called as a dry spot. Right. So in this case, the material is not be dry. Understand it? So time gap in between the diffusion of the water in the from the inside solids to the upper surface, and not be form the not be form that continuous film on the surface. जोपर्यंत मॉइश्चर हे सरफेसला येत नाही तोपर्यंत इव्हॅपोरेट होणार नाही. Understand it? सो मॉइश्चर हे इनसाइडचं जे मॉइश्चर आहे ते आउटसाइड यायला पाहिजे, सरफेसला यायला पाहिजे, तरच ड्राईड होईल. बरोबर. तर काय होतं की इनसाइडचं मॉइश्चर आहे ते कम्प्लिटली बाहेर येत नाही, अँड सो देर इज रिक्वायर्ड टाइम टू डिफ्यूज, right? So that is called as a dry spot. So in this case, the point D, so from the C to D, so is the first falling rate, and the D is D point. It is called as a second critical point, right? So that second critical point. So at the same time, the film of the surface, right? Film of the surface of the water is completely evaporated, right? The film of the surface of water is completely evaporated, but at the same time, the water, the moisture contained the inside is not be coming to the outside, right? But or the surface of the water is completely evaporated. So that point it is called as a second critical point. Then from the D to E, right? So next is that from the D to E, it is called as a second falling rate period. So this is below a second falling rate period. So second falling rate period is very high than first falling rate period. So very steeping curve is again, right? So the second falling rate period is very higher than the first falling rate period, and during that period, so drying the falls even more very rapidly as compared with the first falling rate period. So during this period, rate of drying is depending upon the rate of diffusion of the moisture from that solids, right? So its total rate of drying is depending upon the moisture containing the inside. जोपर्यंत मॉइश्चर कंटेंट हे इनसाइड बाहेर येत नाही तोपर्यंत तुमचा रेट ऑफ ड्रायिंग होणार नाही, बरोबर. सो मटेरियल कधी ड्राय होईल जर टोटल मॉइश्चर हे इनसाइडचं बाहेर आल्यावर टोटल ड्राय होईल, राईट? सो दॅट प्रोसेस इट इज अ पॉइंट ई. सो फ्रॉम द डी टू ई, so this period it is called as the second falling rate period, and at the E is called as a equilibrium moisture content, right? So is the equilibrium moisture content, moisture is constant. So after if you want to try it after that, after giving the heat after that E point, right? So the material is not be dry, and this is totally wastage of that money, wastage of the time. And if giving the direct heat is given, but material is not be dry, because there is a E point is refers as a equilibrium moisture content. We have seen the first there is a lecture is what is the equilibrium moisture content. So minimum amount of the moisture containing the wet solid, containing the solids. So it is called as a equilibrium moisture content. So the material is not be dried until to maintain equilibrium moisture content, and that point is it is called as a D point. So then the beyond the E point, right? So there is a drying rate is 0. Understand it? So the drying rate is equal to 0. It is after that there is no drying. No drying is there, right? So therefore, if you apply the temperature and the moisture, which are remain the constant, temperature and the moisture is remain the constant. So beyond that E point, if you continue the drying, but there is a totally wastage of the time and the energy also, right? So understand this the curve. Then we see the in better manner in the graphical content. So this about if you understand this rate of curve, drying rate. So from the A to B, which are represented as initial adjustment period, right? So during that period, what will happen? So we can this is the initial adjustment period. The hot air is passing to that wet solids, and at that time to absorb that energy, heat energy, and increase the temperature, right? Increase the temperature. But at the same time, right, what are the water containing inside solids which are coming to the coming to that solid surface and then can evaporate it. At the same time, the that is heating is applied to that wet solids, and at the same time there is a evaporation of moisture from that surface. Right? So that's why the temperature is decreasing. Understand it? So if you just apply the heating and there is no evaporation, there is a temperature increasing and no drying is there, right? So that's why so diffusion of that water molecule from that inside solids should be a transfer for the surface of the solids, and then what is the moisture on that surface solid should be evaporated, and that's why after the evaporation, so the temperature is decreasing. So at the equilibrium is reaching when the rate of heating is equal to rate of working, rate of cooling. These are the two aspects are that rate of heating is means we can apply the heat, right? Rate of cooling means that is evaporation. So when the rate of heating is equal to rate of cooling, right? So then that process it is called as it is a initial adjustment period, right? So we have seen that already. After some time, the temperature is stabilized and heating and cooling the rate become equal, right? So the heating and evaporation is it should be equal, and the temperature at that the wet bulb and the dry air the same, and that point it is called as the point P, right? Then is corresponding to the next is the from the A to B and the B to C. It is called as constant rate period. So this is a constant rate period. Again, we can apply the heat, right? And this is then from that heat, so the moisture is evaporating, temperature is constant, the rate of drying is also constant. That is why it is called as constant rate period. Can you hear? Hello, आवाज येतोय?
Yes, sir.
Yes.
येतोय ना?
Yes, sir.
Okay, okay. So in this case, during this period, surface of water is no longer replaced from the inside the solid moisture. Right. So previous slide. So in this case, from the B to C, in the B to C, this is constant rate period. So in that period, the state line is there, totally state line is there, right? It's the temperature and evaporation is equal, right? So means the temperature remains constant, that is the rate of drying is constant. That's why it is a straight line curve, right? So moisture is evaporating from the surface, and again we can replace to that diffusion of the interior surface means can start evaporation started, and same time जे काही इंटरनल सॉलिड इंटरनल मॉइश्चर आहे ते आउटसाइड यायला पाहिजे, and they can appears on that surface of the solids, then it can evaporate it. That process it is called as a diffusion. So diffusion of the moisture from the intact solids inside solids and which are going to the outside surface, and that process is called as a rate of diffusion. So rate of diffusion is equal to rate of evaporation. म्हणजे इव्हॅपोरेशन कधी होईल, जे इनसाइड जे वॉटर आहे ते बाहेर आल्यानंतरच इव्हॅपोरेट होईल. जोपर्यंत आतलं जे वॉटर बाहेर येत नाही तोपर्यंत इव्हॅपोरेट होणार नाही. So that's why the rate of diffusion is equal to the rate of evaporation. So it should be same, right? So जोपर्यंत इनसाइड वॉटर बाहेर येत नाही तोपर्यंत इव्हॅपोरेट होणार नाही. So that's why rate should be same. म्हणजे properly rate of diffusion should be equal to the rate of evaporation, right? So rate of evaporation is equal to rate of diffusion. Understand it? And that the moisture content at the end of the constant point C is referred as critical moisture content. That is called as CMC. So in his next slide, next is after that the CD, right? So what is a CD? In that CD is the first falling rate, right? So you can the curve is totally stepping down, right? And that is called as the first falling rate period of that. So during that period, surface of water is not be replaced by the inside water and not be form a complete continuous film on the surface. Understand it? जोपर्यंत तुम्ही हे केलंय आणि रेट ऑफ जे इनसाइड मॉइश्चर आहे ते बाहेर यायला पाहिजे. समजा बाहेर नाही आलं तर इव्हॅपोरेट होणार नाही. And this dry spot म्हणजे काय, right? जोपर्यंत बाहेर it is time required to the moisture is from the outside to the from the inside to the outside. बरोबर? जे time gap between moisture coming from the inside to the outside. समजा की आतलं मॉइश्चर बाहेर आलेलं नाही, राईट? जो काही तो पिरियड असेल, जो काही टाइम असेल, so in that period there is a rate of drying is for, and that is called as a dry spot. म्हणजे जे काही इनसाइड सॉलिड मॉइश्चर आहे, इनसाइड सॉलिड मॉइश्चर इज कम्प्लिटली कंटिन्युअसली हे आतून बाहेर यायला पाहिजे तरच इव्हॅपोरेट होईल, बरोबर, राईट. आणि कंटिन्युअस फिल्म सरफेसला व्हायला पाहिजे तरच इव्हॅपोरेट होईल. तर काय होतं, हे जे आतलं जे वॉटर आहे ते बाहेर येत नाही, राईट, त्यामुळे इव्हॅपोरेट होत नाही, बरोबर. आणि कंटिन्युअस फिल्म सरफेस मध्ये होत नाही आणि त्यामुळे ते इव्हॅपोरेट होत नाही, बरोबर. So dry spot begins to appear the heat of drying is formed. How do it is called as dry spot? Dry spot means uh, the time gap between there is a moisture containing in the inside solids which are going at the outside solids. Understand it? Right? So there is time. This is called as a dry spot. And in that dry spot, the rate of drying is fall. In त्या प्रोसेस मध्ये रेट ऑफ ड्राइंग होत नाही, कारण इव्हॅपोरेट होत नाही. जोपर्यंत इव्हॅपोरेशन होत नाही तोपर्यंत ड्राइंग होत नाही, बरोबर. सो दॅट पॉइंट इज रेफर्ड एज ए सेकंड क्रिटिकल पॉइंट. सो एट द सेम टाइम at the T point, right, the film of the surface is completely evaporated. We have seen the in figure, right. So film of the surface is completely evaporated. समजा the moisture is outside surface पूर्ण evaporate झालंय आणि inside water तसंच आहे, तर it is not be possible the drying, right. So the rate of evaporation is more than rate of diffusion. म्हणजे रेट ऑफ इव्हॅपोरेशन जास्त आहे आणि रेट ऑफ डिफ्युजन कमी आहे, तर कसं ड्राय होईल, होणार नाही, बरोबर. सो दॅट इज कॉल्ड एज अ फर्स्ट फॉलिंग रेट पिरियड ऑफ दॅट. रेट ऑफ इव्हॅपोरेशन इज मोर दॅन रेट ऑफ डिफ्युजन. कम्प्लिटली सरफेस ऑफ वॉटरला इव्हॅपोरेट होत आहे, पण इनसाइड जे मॉइश्चर आहे ते कम्प्लीट बाहेर येत नाही. Understand it? So this is called as a point D. So that is called as a second critical point. Then after that, so from the corresponding there is a D to A is the last point. So it's called as a second falling rate period. So this during this period, rate of drying is a falls is more than very rapidly as compared with the first falling rate period, right. So this is the hot it is again passed the second falling rate period. Rate of drying is directly proportional to the rate of diffusion, right. So rate of drying is totally depend upon rate of diffusion of the water containing the inside solids. जोपर्यंत the inside the water बाहेर येत नाही तोपर्यंत dry होत नाही, material dry होत नाही, right. So during this period, so rate of drying is depending on the rate of diffusion of the vapor pressure, and which are the vapor pressure is coming on the surface of the solids. जोपर्यंत मॉइश्चर हे सॉलिड सरफेसला येत नाही, अप्पर सरफेसला येत नाही, तोपर्यंत इव्हॅपोरेट होत नाही, right. Then so the point is referred as a equilibrium moisture content, and the total process will be stopped, and there is a rate of drying, the material is dried, but somehow the moisture containing in that period, and that is E point. E point is called as equilibrium moisture content. Understand it? So next point. So beyond that drying rate is equal to 0. After the E point, there is no drying is there, but somehow the moisture containing that the dried solids, and that moisture is called as a equilibrium moisture content. So after that, the temperature and the moisture content is remains constant, right. So if you continue for drying and there is no drying is possible, and there is totally wastage of the time, totally wastage of the energy, and that is possible. You understand this curve? Hello? Is a very important for examination point of view. Hello? Can you hear?
Yes, sir.
Okay.
Yes, sir.
Then next point we will see is a different factor affecting rate of drying. Right, rate of drying. How you select the different dryers for drying the material. So first part is that is the properties of the material being to dry, handle. So which of the property of the material it is? The physical characteristics of when the dry the material. समजा ड्राय मटेरियल असेल तर कुठला तुम्ही ड्रायड यूज करायचा आहे. समजा मॉइश्चर हे कमी आहे तर ते मॉइश्चर आहे तुम्ही अजून कमी करायचं आहे तर कुठला तुम्ही ड्रायर यूज करणार. देन फिजिकल characteristics when the substance is weight. समजा फार मॉइश्चर आहे, अगदी खूप प्रमाणात मॉइश्चर आहे, तर ड्राय करायचं मटेरियल, तर कुठला तुम्ही ड्रायर यूज करणार आहे, इट इज बेटर. देन मटेरियल is a corrosive material. So those are corrosive material. It is that is a corrosive material. It's how the particle size is more, right? So particle size is more. So this material is the crystalline type of the material. So crystalline type of the material, surface area is less. So that's why it's a required time to dry the material, or highest temperature required for the dry the material. Right. So depending upon this, if the cohesive material, the particle size is more crystalline in size, and that's why it is required time to dry. Then toxicity, if the material is very toxic in nature, and during the drying process, right, it may chances the toxicity to the operator also. Right. So we have to consider whether the material is toxic or not. Then the material is very flammable in nature. Sometimes during the drying, it may chances of the increase the temperature. And if the material is very flammable in nature, it may chances of the burning of that the dryer, or maybe is a bursting of the dryer. That's why can consider that whether the what type of the material it is. Then particle size. If the lowest particle size, very fine particle size, is always we increase the surface area, and if you apply the heating to that particular solid material, it can dry it very short period. Then abrasiveness, it is always we have abrasive property, means that the particle size is very crystalline in nature, as the internal structure of the solid is very not uniform, and not it is a irregular size of that particles, and that is called as a abrasive type of the material. Then drying characteristics of the material. So which of the material it is, type of the moisture. So कुठलं moisture आहे त्यामध्ये bound water आहे का unbound water आहे का, both आहे. Right. So bound water is, so this water is cannot be removed very easily, we have seen, right? But unbound water is we can freely remove from that wet substances and dry the material, right? And which of the water containing that, so we have to consider. Then initial moisture content, so how much moisture content initially, then after drying, what is the final moisture of that, final moisture of that, also can consider. The permissible drying temperature means how much temperature should be applied to dry the material. Sometimes if the substance is very light sensitive or the temperature sensitive, right, so we can use the very low temperature to dry the material. Understand it? So we have to consider that whether the permissible drying temperature is appropriate or not, because with that temperature maybe the substance is degraded, the substance is burning, or it's from the carbon, right? So that's why we can consider the probable drying time is required. So how much time required for the dry the material? So we have to in a trial and error basis we can see that. So how much time required for the dry the material, right? Dry the material we have to consider first. If your drying time is more, it may chances of over drying and is totally destroy the material, right? Then flow of the material and from the dry. Quantity to be handled per hour means how much quantity we have to dry. Right. So means if you want to dry the material is 250 kg, right? So which dye is used? If you want to dry the material is 500 kg, so which dye is used? Depending upon the quantity of the material, right? So they have to decide the dye. Then type of operation. So whether this type of operation is a batch operation as well as continuous operation. So batch operation means that, right? Batch operation means that if the one batch is the 100 of kg, so you can completely dry the material 100 of kg, right? So that is called as a batch. So one batch is 100 kg, second batch is 100 kg. So first you start the first batch and complete that first batch, then you can start the second batch. So that is called as a batch wise. Then continuous drying process means that can give is continuous process. Is thousands of kg you can dry it at a time in a continuous process, right? And that is called as continuous batch. Then process prior to drying. So how much processing required for the drying, because it's contain the more moisture, is difficult to dry the material, right? Or difficult to handle that material if the more moisture contain that, right? So first we have to remove some of the moisture, and then you can go for the drying. Understand it? So it is called as a prior processing must be required. The process subsequent drying. So what process should be required for the drying, that also can be considered. Then what is product quality, quantities of that, right? So product quantities means the after this drying, so what are the quality of the product, whether the material is appropriate or not, whether the material is shrinkage, right? If you apply the more drying, it may chances of material is shrink, and the properties of that material is change, shrinkage. So how the material is shrinkage, because if you remove the moisture from that material, the material is shrink, right? So your product should not be shrink as like, right? Then contamination, during the process of that will not produce any contamination. Sometimes during the drying, it may chances of if the previous product is the different. If your previous product is paracetamol and the present we can try the aspirin, right? But the previous product is not be removed completely from the dryer, right? It's getting problem. Then will contaminate your product, aspirin and the paracetamol. That is called as contamination. Then inform it of the final moisture content. So what is the final moisture content in that the way to also consider. Then decomposition of the products. So during drying, what will happen to that happen to that material? Whether is the material is appropriate or not, whether it's decompose or not, what are the apply the time as well as the pressure as well as the temperature. Right. Rate of subdivision, the product temperature, how much temperature should be applied to that by the material, so you can improve the quality of that product. Then bulk density. So what is a bulk density? Bulk density is what is the density of that particular solids, right? Whether it's a low density, whether it's a high density, right? So every time the density is very important for the powder material. If the low density material which are fluffy in nature, the weight of that material is very low, and the low density material it is difficult to flow appropriately, right? Difficult to flow appropriately. That's why the bulk density will be calculated. Then recovering problem, so dust recovery. So during drying, it may chances of the some of the crushing of the material, and the material is more dry. And after the material is more dried, it's from the dust, right? So dust is a again you can how to collect the dust from the instrument or the dryer, and how you collect that, so that is also considered. Then solvent recovery. So during the drying, if you use the if the material is contained in different solvents, right? So how to recover from that from that material from the during the drying. So that procedure also can be required for that. Then different facilities are available in the laboratories, right? So whether the pace is available, if you want to install some of the dryers, so what is whether the pace is available, right? Whether the temperature machinery is available, right? Whether the humidity is controlled, right? Humidity is controlled, relative humidity is controlled. The cleanness of the air. So in that area, the air should be clean. Then available fuels, what is the required the fuels for the dryer? So whether it is available or not. Electrical water, electric power, whether it is available or not. So source of the wet feed, right? So the weight feed means the feeding the wet material to the dryers. So continuous feeding, right? It should be possible, and that is the sources. Then permissible noise during the processing of the drying, not be any noise is producing, no any much vibrations, no is dust formation, and not be producing the heat loss. So this is about and the exhaust gas outlet. So so during the drying, it may chances of the gases also can be removed from that material. So after the gas is removed, should be exhausted the gas from that the dry. So this is also very important. Again, if not be exhausted, it remains in the dryer, and it may chances that with the gas, chances of the busting or the maybe some of the major accident is possible with that. Right. So these are the different classification of the dryer. The first classification, these are the different dryer or the different equipments which are used for dry the material. Right? This is the equipments. This is the first category. Is if you want to dry this for the solids, and if you want to dry the some paste or the some slurry is there. right? How we can dry it and which instrument we can use for that, right? So first it is a we can see that for the solid drying is particularly we can take the example of that granulation. If you want to wet granules, if you want to dry the granules, so how can do that, right? So there's the both the process we can the three processes are there can dry the solid substances by convection, conduction, and radiation, right? Convection is means contain that you can use the mechanical dryers, right? So you can just apply the heat and the air, right? So that is called as convection, right? Then conduction means we can apply the vacuum air. Vacuum is applied, right? And next is the radiations. Different UV radiations or gamma radiations we can use for to dry the material, right? The different lamps are used for that is called as radiation. Then in convection there is a two processes are there: batch process and continuous process, right? So batch process, the size of the tray dryer is a very small size. If the hundreds of kg of the material, if you want to dry it that, right, we can use the tray dryer at that size, right? Or the fluidized bed dryer, we can use at the batch process. If the hundreds of kg is there, we can use for that dryer. But if the material is more, right, if the thousands of kg you want to dry it, and that is called as a continuous process. So at that times we can use tunnel dryers are there. Tunnel dryers, the belt dryers, convenient dryers, it's called as conveyor dryers. So the process is continuous, right? And we can just the passing the material to the inside to the dryer, and after some time we will dry the material and going outside. So this is no handling is essential, not be essential for the handling, right? So just you can feed up the material, and after drying we can materials which are going outside. So this is called as continuous process. So the tunnel dryer is used, is also is called as a belt dryer, is also is called as a conveyor dryers. Rotatory dryers are there, which are largest size of the rotary dryers. Then turbo dryers are there, right? In conduction, there is again the batch process and the continuous process. The vacuum is used. There is a vacuum oven we can use for that. We can particularly use the temperature as well as vacuum, so dry the material. The freeze drying with a minimum temperature, we can dry the material, and if generally use a freeze dryer for, so those have the lights, the temperature sensitive material. With the, if the material is degrade with the 40 degrees centigrade, we can dry the minimum temperature. That's what it is called as a freeze drying. Then in a continuous process, we can use pneumatic drying is there, pneumatic dryers. So these continuous dryers are there. Then if the material is paste is there or the slurry is there, can use as the agitator type of the dryer. So agitator type of dryers, and we can dry the material of the paste with the agitator type of the dryers. If the material is very solution form, right, then you can use the convection process or conduction process. In convection process means that is got it's totally mechanical process are there. You can apply the dry heats and also can dry the material. So it is called as a rotary dryer, conveyors are there, tunnel dryers are there. But in conduction process, we can use a drum dryer, right? The drum dryers, we can pan dryers, we can use a vacuum, right? Pan dryers or rotary dryers or the spray dryers are there. So both all this
Excuse me, sir.
vacuum, and that's why it is called as a conduction process. So the during the drying,
Sir.
you consider the different